linear inequalities in two variables. And we've learned about linear inequalities before, but in one variable. So if you remember earlier in this unit, we were solving linear inequalities with one variable, where it's just like solving an equation, except you just had to watch out for when you divided or multiplied by a negative number, then you had to take your sign and flip it. And so now we're going to look at how we can solve linear inequalities in two variables. So when we have two variables, we can graph it, just like we can with an equation, like that's in slope-intercept form, like y equals 3x plus 4. We can graph linear inequalities, and a lot of it's similar, but there are some differences. Okay, and so your EQ is how do you write and graph linear inequalities in two variables, and your I can statement is I can solve a linear inequality by graphing. So that's what we're going to try to accomplish today. Some vocab: a linear inequality in two variables is like a linear equation, okay, in two variables, but we have an inequality symbol instead of an equal sign, and our solution is a shaded half plane bounded by a solid line or a dashed line. So that's different. The symbol's different. We're shading half the picture, and sometimes our line is dashed. Okay, that line that could be dashed or solid is called the boundary line, and it divides the coordinate plane into two half planes. It can be solid or dashed. And this is the basic overview of graphing inequalities. So you have to understand how you graph a linear equation. Okay, so we're going to think back to how we graph linear equations that are in slope-intercept form. But when we graph the linear inequality, instead of that equal sign, we're going to have one of these symbols here. So we could have less than, we could have greater than, we could have less than or equal to, we could have greater than or equal to. And so depending on which symbol you have will determine which type of boundary line you will have. If it's the less than or the greater than, our line is dashed. If it's greater than or equal to, less than or equal to, it's going to be a solid line. Okay, so that's one part. The other part is we have to shade half our picture, half of our graph. So depending on the symbol will determine if we're going to shade under the line or if we're going to shade over the line. So here, where y is less than this stuff, or where y is less than or equal to this stuff, we want to shade all the values of y that are less, okay? And if you think about the y-axis, okay, the negative numbers go down, so we shade below the graph. The opposite is true for when y is greater than some stuff or y is greater than or equal to some stuff. Okay, so where is our y value greater? It's as you go up the y-axis. So in this case, we shade above. All right, so here's your first interactive slide, and I'm going to give you 2 minutes to do this one. I want you to have student pace mode on so you can go back and look at those rules and see if you can figure out which of these four graphs you think shows that inequality. Y is less than or equal to -1/3 x plus 2. Think about what that line would look like if it was just an equation, and then also think about what I just showed you on those previous slides, and you can go to them and try it. I'm going to give you 2 minutes to do that. Sounds so glitchy. Alexa, play electronic music. Alexa, play EDM.
Playing EDM music from Apple Music. This world was not afraid of God, just a
Alexa, pause. Okay. I don't know what happened to the timer. That was really weird. It like stopped going. Well, anyhow, I'm going to come back to our Pear Deck slides. So what I'm going to have you guys do is I'm going to stop student paste, and I want you to come back to our Google Meet. All right. So click back to the Google Meet, and we're going to go over the correct answer. But let's first see what you guys came up with. So I got 8 of 10 of you to respond. There's 22 in the meeting. 2 of those are me. So there should be 20 students in the Pear Deck. So if you're not in here yet, you need to get into it, please. The link's in your week at a glance. But what you guys came up with, all right, so someone said D, 2 people said D, looks like 4 people said B, and maybe 2 people said A, or that star is just sitting there, I'm not sure. So, you know, there's different ways to start this problem. One might be to look for what is the equation of y equals negative 1/3 x plus 2, which graph would match that? Or another thing you can do is, you know, look at these rules here. So the symbol, right, means a certain type of line. So we had the less than or equal to, I believe. Yes. So that has to be a solid line. But if I look at these 4 choices, they're all solid lines. So that doesn't really help. If I look at where we're shading, okay, y is less than or equal to, that means I have to shade under the line. That should help, right? So A is shaded under the line, B is shaded under the line, C is shaded over the line, and D is shaded over the line. So it's not C or D. It can't be C or D. It has to be A or B. Now I could look to see what the y-intercept is. 2. This graph A passes at 2. This graph B passes at 2. That doesn't help me narrow it down any further. So I'm going to go to the slope next. My slope is whatever's in front of the x term, negative 1/3. Well, without even counting the slope, one of these is a positive slope and one's a negative slope. Okay, this is going, as you go from left to right, it's going downhill. This one, as you go from left to right, is going uphill. So this is a positive slope. It can't be B. My only choice at this point, geez, guys, cat and dog fight. Sorry. You okay? My only option here is A. A is the correct answer. All right. So if you have your star on B, you can move it back to A, because A is the correct answer. All right, I'm going to hide your responses, and we're going to try another one of these. All right. Again, multiple choice. Drag your icon to where you think the correct graph is of y minus 2x is less than 3. But that's not in slope-intercept form, is it? So let me just open up a whiteboard, Jamboard real quick to show you. I'll share it with you in just a second here. All right, so the equation that I am starting with is y is less than negative 2x. I'm sorry, y minus 2x is less than 3. So I got to rewrite it so that it's in slope-intercept form. Okay, so that means I need to get this term here to the other side, right? So it's going to become y is less than. And when you move it to the other side, it's like adding 2x, right? So this is 2x, it's positive. And then this 3 is positive, so plus 3. So that's the equation. You're looking for that equation, and then you're looking for the correct type of line and the correct shading. Okay, so let's give you 2 more minutes. Play this one. Alexa, unpause. So go to your Power Deck tab, try it. You're in student mode. You can jump back to the informational slides. Got another minute. Alexa, pause. Okay. So let's see. Only 6 of you have responded, but we are up to 11 students. So we got 1 more student. I'm going to send out a mass Go Guardian announcement because there are some student. Well, I don't know if I need to send out a mass one. There's not that many people online that aren't doing what they should be. There's like a couple. All right. So one person said A, looks like 4 people said B, 1 person said C, nobody said D. And so remember, we rewrote this equation so that it was actually y is less than 2x plus 3. So my slope is positive 2 and my y-intercept is positive 3. So maybe I'm going to look for that line first, or a line that looks like that. Positive 3, a y-intercept of positive 3. Well, C has a y-intercept of positive 3. A has a y-intercept of negative 3, so it's definitely not A. B looks like it has a y-intercept of positive 3, so it could be B, could be C. D has a y-intercept of positive 2. It's definitely not A or D. It has to be C or B. Lesson symbol, that means I have a dashed line. B and C both have dashed lines. So the difference here is the slope. Okay, one's slightly steeper than the other, and the shading. So C is shaded above the line, and B is shaded below the line. So if Y is less than what I'm graphing, and I go back to this slide here, Y is less than, that tells me I shade everywhere where Y is less, small, negative, all right, underneath. So that's the underneath sided of shading, which means B has to be the correct answer. So B is your correct answer here. All right, we're going to do 1 more of these. Again, it's an equation that we have to put into slope-intercept form. So I'm just going to share the Jamboard with you real quick, clear the frame, paste this here. And to get this in slope-intercept form, now my problem is that I have this 3 in front of the y. The x term's in the right spot. The 9 is in the right spot. The y term's in the right spot. It's just that the coefficient is wrong. So to get rid of that, we're going to divide by 3 and then do that everywhere. And this turns into y is greater than, well, 3 divided by 3 is 1. You could think of it as 1 over 1x or just 1x. Those are all the same. Plus 9 divided by 3 is 3. So this is what you're looking for this time. Let's give you another 2-minute timer. Alexa, unpause. So Alexa, pause. Okay, so time's up. We are going to take a look at this problem here. 3y is greater than 3x plus 9. You know, there's lots of ways to go about trying to figure out which one matches this. You can look at the symbol, okay, that you have. In this case, it's greater than, does not include the or equal to. So this tells me it has to be a dashed line. All right, that's good. Look at the stars that we have. The 4 of you, thank you, 4 of you that responded are on the 2 possibilities so far. It can't be A or D because those are solid lines. We rewrote this equation, and I'll show you here, to y is greater than 1x plus 3. So which of these graphs has a y-intercept of 3, and which of these graphs has a slope of positive 1? If I look at B and C, they both cross at positive 3 on the y-axis. They both have a positive slope going uphill, up 1 over 1. This one's up 2 over 1, so it has to be this one. And another thing is if y is greater than, we're shading above. All right, so we have to make sure we shade above. B shades below. So this is actually less than. That would be the less than symbol. So C is your correct answer here. All right. So we kind of looked at some multiple choice problems. We're figuring that out. And now kind of, you know, I'm going to show you the steps basically. So if you are graphing a linear inequality, these are the steps that you're going to do. First, graph the equal line. Okay, so imagine that you don't have that inequality symbol, that it's just an equal sign. So you're going to graph that line and then shade in the correct area. These are the 3 steps. So step 1, rearrange the equation So y is on the left and everything else is on the right. What that says is you're going to put it in slope-intercept form. Y is on the left by itself, and then you have your x term and your constant. Second step, you're going to plot the y equals line. All right, now as you're graphing this, what I would suggest you do is make it solid to start. We're doing everything digitally right now, so on the next few slides, we're going to be doing that. But you can then use the eraser tool to go back. So if you did need a dashed line, make one straight line first and then go back and erase out so it looks like a dashed line instead. But you only use a dashed line when the symbol is less than or greater than. If your symbol is less than or equal to or greater than or equal to, because it also includes that equal to, it includes the line, then we make it a solid line. It's kind of like when we were graphing linear inequalities in one variable. Do you remember how on a number line you can have either an open circle or a closed circle? You would have a closed circle when you had the greater than or equal to or less than or equal to, because it includes the point. Same thing with the line. It's solid because it includes the line. Whereas if it was less than or greater than, we had an open circle because it wasn't including the point. And that's why the line is dashed here. It's not including the line. So you could think of it like that. And then the last one is shade above the line for greater than symbols or greater than or equal to. Or shade below the line for less than or equal to. So, you know, depending on if it's those two that start with greater than, that's everywhere where y is greater than, above, or less than, below, where everything is less than. Okay, so these are our 3 steps, and we're going to look at what this looks like as far as just examples being done. Okay, I'm going to take you off student pace for a second here. So we have a graph of y is less than or equal to 2x minus 1. The 3 steps are written here that I just talked to you guys about. Step 1, check to see where y is and where your x term is and where your constant is. Well, this is already set up. Y is on the left by itself, 2x is here, and then our constant is here. Okay, so we're good. We don't have to do anything for step 1. This is already ready to graph. Step 2, we're going to graph the line as if it was an equal sign. So y equals 2x minus 1. We start at -1. You always start with your y-intercept, and then you use your slope to plot more points and graph. The slope is positive 2, which you can also think of as 2 over 1. So if, from your starting point, if I go up 2 units and then go to the right 1 unit, I come back to the line. Up 2 over 1, up 2 over 1. So that's our line there. And then the last thing to do is shade. Notice that also in step 2, we're keeping this line solid because of the less than or equal to. Step 3, shade. It's less than or equal to, so everywhere y is less, below the line. And that's it. Here's another example. 2y minus x is less than or equal to 6. Well, here, we're going to have to do step 1. We have to rearrange it so that y is on the left by itself. And that's what's being shown here in these steps. We are adding x to both sides. And then that gets all the pieces in the right spots. But then we have to simplify a little bit more. We have to get rid of the 2 and divide everything by 2. And you've done this a lot just with equal signs instead. This was a Delta math assignment where you started with standard form and you had to go to slope-intercept form. It's the same thing, really. The only difference here is that instead of the equal sign, we have an inequality sign. But you're still using all the same rules of algebra. If I did happen to divide by a negative, I would have to flip my sign. But we don't see that right now. So we're dividing by a positive, everything's kosher. Step 2, we're going to plot y equals 1/2 x plus 3. Okay, because that's what we figured out our slope-intercept form is, but we're going to plot it with an equal sign because it's the same rules. You start at positive 3, which is here, and then you use the slope of 1/2. So you rise 1 and you run 2. You rise 1, you run 2. It's less than or equal to, again, this includes the equal to part, so the line stays solid. Last step, shading. Less than or equal to, so shade everywhere, y is less, that's below the line. One more example, and then you're going to try this. Graph 1/2 y plus 2 is greater than x. Step 1, we have to rearrange it so y is on the left by itself. So this time, it looks like y is in the correct location, x is in the correct location, but 2 is in the wrong location. So I'm going to add 2 to both sides. That then puts all the pieces in the right spot. Y term, inequality, x term, constant. 1/2 can't be in front of y. Okay, I have to isolate y. So to get rid of 1/2, we multiply by 2. 2 times 1/2 is 1. Do the same thing to the other side. 2 times x minus 2. It's a distributive property. 2 times x is 2x. 2 times 2 is 4. Bring your subtraction sign down. So now I have an equation, an inequality that I can graph by thinking of it as a slope-intercept form, which is what I have here, y equals 2x minus 4. So this is the first time in step 2 where our symbol is going to be telling us to make a dashed line because it doesn't include the equals to part. It's just greater than. So it doesn't include the line. So I have to make sure that my line is dashed. But again, you start at -4. That's your y-intercept. Then you use your slope, up 2 over 1, up 2 over 1. That's the pattern. Last step is to shade. Y is greater than. Now we're going to shade everywhere y is larger than the line, bigger than line, above. Okay? So we have 2 problems I want you to try. I don't care which one you want to start with. Pick one. Step 1's done for you. Look, y is less than 1/2 x plus 4. So it's already in what we could call slope-intercept form. Number 12, y is less than or equal to -3x minus 5. Also, this is already set up, ready to go to graph. Pick one of these to start with. You're going to use those drawing tools. And so this one, see, it's less than. That one's going to be a dashed line. This is less than or equal to. This is going to be a solid line. They're both going to have shading, though. And let me just show you real quick. If I open up a student version. I gotta get all the way to 11. Okay, so if I wanted to make a dash line, you can draw a regular line, okay, and then go back and get your eraser tool, and then just make holes in it. Okay, and that makes it dashed. That one looks a little like Swiss cheese. I don't know, I don't like that so much. I want to start over. I'm way too picky. I like making my lines typically, making this the smallest size. All right, so if you make a line, you have your arrow at the end. Lines always have arrows. Doesn't matter if they're dashed or not. They always have arrows. And now I can use this size tool. Now it'll actually make dashes. Doesn't look like cheese. Okay, so that's how you can make a dashed line for this one. And you are going to be shading. Y is less than. So which side are you going to shade? You are on student pace mode. I'm going to give you feedback as you're working on this. Okay, we have 10 more minutes of class. We will go over the answers at the end. But let's try to spend maybe like 5 minutes just working on this. And then we'll go over the answers in 5 minutes. Let me find you a 5-minute timer. Alexa, play. Okay, Alexa, pause. Okay. All right, so you guys, I'm gonna take off student pace for a second here. And I want you to come back to our Google Meet tab, all right? And let's take a look at what some of you came up with. I got 8 of you to try number 11. As far as number 12, 3 of you tried it, which is fine. You probably only had time to try one. Ooh, this is a very nice shading. Y is less than, definitely shaded on the correct side. The line is solid, which doesn't match the less than. So we do want to go back and turn this into a dashed line. Let's see, it passes at +4. It passes at, the y-axis at +4, awesome. The slope is 1/2, up 1/2. So this graph is almost perfect. The only thing they have to go back and change is they need the little, that was a huge dash. Okay, so they're working on it right now. Let's see, right here. Here we go, we got some shading on the right side. We got a dashed line, it passes at 4, the slope is correct, good. The only thing you're missing here is those arrows at the end of your lines, and it's perfect. Although, I don't really know what the rule is. If your line goes at the edge of your graph like this, I'm not really sure if you need the arrows. A lot of times you won't see them, so this could be perfect just like that, but I do appreciate the arrows, nice work. This one shaded correctly, dashed line, we passed that 4. The only problem here is the slope is slightly off. The slope is rise over run, 1/2, and we did up 2/1. You want to do up 1/2, but you're very, very close. This one shaded correctly, dashed lines, yes. Passing through 0, we want it to pass through 4 because of the 4 right here. So this line should be shifted up. And I think your slope is 1, so you want to make sure your slope is 1/2, up 1/2. So shaded correctly, but there's some other issues like the last one. This passes through 4, looks like it's the right equals line, but then we're going to go back and add to it. Okay, so you can kind of see what's happening here. If I go to this one and show some responses, let's see. I want it to cross at -5, -5. Okay, here's one that crosses at -5. The slope, -3. Well, it is going downhill, so this is up 1, 2, 3 over 1. It's a little hard to get it perfect, so I'm just going to let it slide up 3 over 1. It looks pretty close to -3. And they erased their shading, which I wish they did not, because they were correct. Y is less than or equal to. It should be shaded below, because if we look to see where it crosses, we want to make sure we shade on the side where the numbers are getting smaller. So that is this side of the line. So that is correct. You should have it shaded where you had it shaded. -5. Yeah, so this is your starting point. This is a good start to this problem right here. -5. I'm going to put you back in student pace mode. Okay, and I want you to go back and finish these 2 lines. We kind of talked about what you need to do for each one, and we have 2 more minutes. So I'm going to do the first one with you so you can see it. Well, actually, we looked at enough examples where the first one was done correctly. I'm going to do the second one with you so you can see that one. So I'm going to share with you my screen where I'm working on the very last slide, and you guys are in student pace mode. Okay, so the steps here are, you know, is it in slope intercept form? Yes, it is. And then I'm going to step 2, I'm going to graph this line. And so I'm going to use a point to represent -5, which is my y-intercept. So let's use purple. That's too small of a point. Let's make that larger. Okay, there's my first point. And then from that point, I'm going to plot more points using the slope, which is -3. And so if I put a little text here, y-intercept is -5, and slope is -3, or -3 divided by 1. Okay, is this going to let me? Yeah, okay. So this is what I'm working with. That's why this -5 is here. That is blue. Not like that, I can't undo. It bothers me. Now this looks like an eyeball. All right, so let's come back to plotting more points. I'm going to use the slope of -3 or -3 over 1. So it should be going downhill. From here, I'm going to count up 1, 2, 3, and over 1. And then I repeat it. Count up 3 over 1, up 3 over 1, Now, because I am doing this by hand, I'm going to keep going until I can't put any more little dots on here. Down 3, over 1. All right, so I have all the slope as I can. It's pretty straight. It's not perfect, but you know, it is what it is. And now I'm going to draw a line connecting the dots. I'm going to make arrows at the ends of my line. And I'm going to leave it solid because of this equal to part in the inequality. And then the last step is to shade. So let's use a highlighter to shade. You can shade with whatever color you want. Y is less than. So where is Y less than? I look at, you know, where this crosses the Y-axis. That means I need to shade this side. Okay, so I'm shading everything over here. And that's it. That's all I got to do. All right, class is over. You guys can stay on if you have questions. Otherwise, you're free to leave the meet. Angel, what are you? It's B. You can tell. Okay, that was from earlier. Angel, it easy.